Hi dear students, welcome back to computer science class. We have already completed functions in Python and we have seen number of topics related to functions like what a function is, how can we define functions, different components of functions, and how can we pass parameters to function, and of course how function can return value or values, concepts like recursion and of course iteration and modules in Python. And now we are heading to our second chapter. It's all about using Python libraries. And we have already seen what a module is. Module is simply a file that contains functions that perform related tasks, right? So in this chapter, when we listen to the term library or module, what comes in our mind is definitely as a programmer or as a developer, one of the most important, most finest features what we are looking at is the availability of large or huge library, right? Support of huge library. That is what we are going to discuss. In this chapter, we are going to look mainly at modules and related aspects of modules. Okay, so actually what do you mean by module? Module is, as I told you, module is simply a file that contains related functions or functions that perform related operations, right? So we can just look at the term module, library, packages, all those kind of stuff, right? Okay, before heading to the topic, how we are solving a problem. In the first chapter function, we have seen how we solve problem, right? When we get a problem, somewhat a bigger problem, we divide the problem into sub problems, right? And each of these sub problem can be termed as module, right? And each of the subproblem, in each of the subproblem we can have different or various functions, right? It's not comprised of a single function. We can have multiple functions that perform related tasks, right? So when the program become complex or larger, we need to arrange it, we need to organize, and it's of course a great task, right? In function we have seen when we get a big problem, we divide the problem into sub problems, or we can say functions, and each function perform a specific task. When the number of functions increases, when we have number of functions, many number of functions, what we do is we have to organize them. We have to organize them in a meaningful way. That is what the use of module is, right? A module is simply a file that contains functions, or a module is simply a file that contains Python code. When we break a program into modules, each module should contain functions of related tasks. We can make it some more simple. Let's consider an example, of course, school management software, okay, or a system. Okay, so we'll have a number of modules. A module for managing your academic data, right? A module for managing your non-academic, a module for managing your official data, a module for managing your fee. Let's consider fee. And in fee module, we'll have number of functions, right? Number of functions which are related to fee. There will not be any function related to academics. We will not include any function related to academics or non-academics or any kind, any other kind in fee. Fee module consists of functions related to fee actions, right? Fee related operations, fee related tasks. That is what the concept of module is. Let's consider one more example, our textbook, right? We have already seen that our textbook is our problem. We divide the problem into sub problem, as I told you in our previous classes. Okay, so when we consider function, we know we can take function as our module. Okay, when we consider function as our module, we have topics, right? And topics can be considered as functions. And what's the specialty of all these topics as functions? In the chapter functions, we have the concepts or we have the topics related to functions. We don't have any topic related to data file handling. We don't have any topic related to data structures. We have topics related to function only. So that is what a module is. So when we consider our first chapter function as a module, we will have the topics related to function only. We will not have any other topics. Okay, so that is what the concept of module is. So that process of division is called modularity, and it's called modularization. And modularization, the advantage of modularity or modularization is the program will be easy to understand. If it is easy to understand, it will be very easy for us to test and maintain the software or maintain the program. So far we do programs with limited number of lines, right? You can see small programs, factorial, Fibonacci, all those kind of programs having limited number of lines. But when you move on to your project, we'll have more number of lines, right? Thousands of lines may be there in your project. But just think of a software, a complex software or a high-end software, okay? We'll have millions of instructions, right? So when we have millions of instructions, how to manage it easily, both as a programmer or as a user, okay? Just we can leave the user, okay? As a programmer, how to manage it efficiently or easily, just making the MES modules, right? We have to arrange these millions of instructions in a better way, so we can manage it very easily. So we are making use of modules for that purpose. So in a program we can have multiple or many modules, and each module consists of different functions or various functions, okay? So modularization helps us to understand the problem very easily. We can make it to be tested easily, and of course maintain the software easily, okay? So these are some of the things related to functions, and we have some commonly used modules that are used for generic purposes are called libraries. Then we know every Python program or every program consists of these three components: packages or libraries, modules, and functions or submodules. You can see all these in a program, right? We can have functions or submodules, and a number of functions can be organized as a module, and modules, collection of modules is libraries, okay? Then we can try to connect these three terminologies: modules, packages, and libraries, okay? So we know what a module is. A module is a file that contains definitions, functions, variables, constants, and some statements, and of course classes and objects, okay? All this kind of stuff. That is what a module is. Then what is a package? Package is a directory of modules. It's simply a directory of Python modules, okay? Then a broader classification, that's what library is. What is a library? Library is just a collection of packages, that's it. Library is just a collection of packages, various packages. Then collection of modules that together cater to specific needs, that's what library is. What? Collection of modules. It's a collection of modules. It's a collection of packages that cater to specific needs. For example, math library. Math library consists of math operations, right? Mathematical operations. So that is what libraries. So these are the three terminologies related to Python library, okay? The smallest component is module. Then collection of modules, directory of modules is what packages. Then collection of packages is what libraries. So on the top there comes library. Then in a library we'll have multiple packages, and of course in each package we'll have multiple modules, okay? And each module we can say we'll have multiple functions that perform related tasks or connected operations, right? Okay, these are some of the inbuilt libraries, okay, packages. We know for web framework, for faster web development, we have Django, okay? We're using Django. And we have Pygame for game development, and for scientific computing, scientific calculations, we have NumPy, right? And we have number of packages available here in Python, and that is the specialty of Python programming language, availability of or support of very huge library. So we can make the program very fast. We can develop the program at a very faster rate. So we can save time, we can save money. That is the advantage of having such a huge library, okay? So this is all about Python module and its kind of operation, okay? Let's have a revision on this. What is a module? Module is simply a file that contains related functions, right? So when we get a problem, we divide the problem into subproblems, and each of these subproblem can be organized as each of the subproblem can be termed as a function, and each of the related functions can be organized as module. When we break the problem, each module should contain related operations, right? And the process called modularization. and we have seen number of examples for modularity or modules. Example, fee module, and in fee module we'll have number of functions, right? And each of these functions will be connected, related functions related to fee operation, nothing else. Okay, there won't be any academics, there won't be any non-academics operations in fee. The same way in the chapter function, we will have topics related to function. We will not have any other topics which are not connected to related to functions. Okay, that is what module is, and modularization helps us to make the program easy to understand, easy to test, and easy to maintain, of course. Okay, then we have a commonly used module which are used for generic purposes. That's what library is, and there are three components: packages or library, modules, and finally what functions or submodules. And what is a module? A module is a file that contains definitions, functions, constants, variable, class, objects, statements. Okay, all this kind of stuff. Okay, then package is a directory of modules, and what is a library? It's a collection of packages, right? We have math library, and it consists of mathematical operations or functions that perform mathematical calculations, and we have some built-in Python library or packages, okay, for performing web framework, web development, game development, and scientific computing. And we have a number of other packages also here in Python standard library. Okay, next we have modules in Python. Actually, we know modules are used to categorize our Python code into smaller parts, right? So statements, functions, variables, constants are defined, and classes are defined there in Python module. Or Python module defines actually what are the ingredients of a module: functions, variables, constants, classes, objects, and some other statements. Okay, so Python module consists of all these components, and we know module categorized. Actually, it consists of functions of related tasks, or which categorize program into smaller parts. That's what modularity is. Okay, then we can look at some of the advantages of modules, and we have already seen we can make modules, and we can import functionality. We can have reusability, it's another feature. We can logically arrange, we can solve it easily, we can make it understand easily. Okay, we can manage it easily. Okay, this is some of the advantages. We can look at one by one. First, ability to import functionality. We have built-in modules and user-defined modules, right? If whatever it is, either built-in or user-defined, we can import it to our program. That is what import functionality. So Python module provides import functionality when we define our module or using built-in module, which offers import functionality. Second is reusability. That is, we can reuse the module in some other program. Python module can be reused in any programs. When we use one module in one program, which can be used in another program also. That's what reusability is, using again. Okay, then logically organize our code using Python module. We know at the time of creating a module, we are making all the related functions to form a module, to build a module, right? So we can logically arrange, we can logically organize our code using modules. Then easier to understand and use. When we make our program module wise, so using the concept of module, it will be very easy for us to understand. Just like completing or making our textbook. We have computer science with Python as a textbook name. That's our problem name. Then we divide into different units, each unit in different chapters. So what is the logic? That's a best practice to manage it, to understand it, to solve it. Okay, so the same strategies, the same pattern is followed here in programming also. That is called module or modularity. Okay, so it will be very easy for us to understand and use the code. Then categorization. Similar attributes can be joined to form a module and can be used in a single module or as the same module. We know in a module, in math module, we have mathematical operations. Okay, in fee module we have fee related operation. So similar attributes into same module or similar attributes into single module. Okay, then finally we have which reduces the complexity. Okay, using Python module, programs complexity can be reduced. So these are some of the advantages of modules in Python. Then we have module names. We have already learned this topic in functions in our first chapter. Module name. What is module name? Name of the module. That's it. Okay. A module name means name of the module. Actually, we have a variable. We know file name with .py extension. That is what a module name is. For example, empty.py. Empty.py. Here the module name is empty. It should be ended with .py extension, or we must have .py extension. Otherwise, the problem is it will be difficult for us to import. It shows error. Okay, if we don't have the extension py, the module cannot be imported to the program. Okay, that's what the problem with not including .py is. So here empty is the module name, and we know we have a variable name. You know the structure of the variable underscore name underscore. That is it. Variable name. Okay, variable name is. Okay, we know name contains. Name is a variable that contains a module. Module name. Variable that hold the name of the module being referenced. Here, what is the name? That is empty. Okay, so name is a variable, or we can say it's a constant. Okay, which stores or which holds the name of the module. Name stores name of the module. That's it. Okay. Then we have main. What does that mean? We have already seen it. We have already learned it. What is that? The current module or the module which is being executed. So suppose a module empty.py is executed. So what will be the value of main? It will be empty. Okay, it will be the name empty. Okay, so main is a name or the current module or the module being executed. The module which is being executed, or the current module. That is what main is. Okay, so when empty.py is the current module or empty.py is the module which is being executed, name will be assigned with main. Okay, or the value of main will be empty. Okay, so that is what main, the specialty of main is, and we have already applied this main. Okay, the name of the module is stored inside a constant called name. Okay, here what name is it? Name is the a variable, or we can call it as a constant also. Okay, which stores the name of the variable, and main the current variable or the current module or the module which is being executed. Okay, so this is all about modules in Python, and module means it is used to categorize Python code into smaller parts, and statements, variables, constants, functions, classes, all are defined in a module. We know a module categorizes Python code into smaller programs, and module consists of all these components, right? All these components are the ingredients of a module. Then advantages, which provides import facility or import functionality, then reusability, then logically arranging the code, then easier to understand and reuse, then categorization. Similar task can be made into a single module, okay, or the same module. Then reduces the complexity. Then module names. Module name means name of the module, simply name of the module, and it is ending with .py. If we don't have .py extension, which is we cannot import it to the program, then we have a variable name that contains name of the variable, and it is of the form underscore name underscore. And we have another statement underscore main underscore. What is that? That is the current module or the module which is being executed, okay, and which will be assigned with main. That's it. Then outside name. What is that name? Name holds the name of the module which is being referenced. Okay, so this is all about modules, introduction to modules, and you just go through it. Okay, we have already seen it, already learned it, but just go through all these topics, and we have gone specific. Okay, not in a general way, we have gone specific. So just go through all these topics very thoroughly, and all are very important. We have to use it in the coming programs. Okay, so this is all for the time being. Thank you for watching. Have a nice day. See you in the next video.